Basic trig identities. Today we're going to learn the basic trig identities that we're going to use as we begin to solve trig proofs. First of all, what is an identity? An identity is an equation that is true for all values for which the values are defined. So for example, if I were to write an equation, tangent of theta equals 1. Well, obviously that's not true for all values, because if I put 45 in there for theta, tangent of 45 is 1. But if I put in 30, then it's not going to be true. So this would not be an example of an identity. It's only true some of the time, depending on what I plug in. If it was a true identity, it would be true for everything. So before we start looking at what a real identity is, we're going to recall from our unit circle. Remember that in a unit circle, r was always 1. So we learned that the sine of theta was y over r. But if r is 1, we can say that our sine of theta is just y. Cosine of theta was x over r, but if r is only 1, then I can write it as x. Tangent's not going to change, it's still y over x. Cosecant is usually r over y, so I'm going to put it as 1 over y, replacing the 1 for r. Secant will be 1 over x, and cotangent will be x over y. So let's recall from our unit circle. If I draw in my terminal ray here and I drop down my perpendicular to make my right triangle, we define this as x, this is y, and this is r. We can get one identity because for a right triangle we know that what's always true? Pythagorean theorem, right? So I can say that x squared plus y squared equals r squared. And this is an identity because it's always true. Okay, whatever values, as long as it's a right triangle, Pythagorean theorem is going to be true. But let me now look back up here, and I'm going to replace my cosine here is x. So instead of putting an x here, I'm going to change it to cosine squared of theta. Plus, instead of y, I'm going to replace that with sine. So I'm going to put sine squared of theta. And then r is 1, and 1 squared is just 1. This is an example of an identity. Okay, it's going to always be true for any values of theta. So some of these identities you already know. The first ones are the reciprocal identities. So for example, if I wanted to do cosecant of theta, we know, and I don't know why this theta is here, but we want to know what cosecant of theta is just the reciprocal of sine. So remember we put 1 over sine of theta, and you can write that already because you know they're reciprocals. So we can also write that secant of theta is 1 over cosine of theta, and cotangent of theta is 1 over tangent of theta. But then I can also go the other way, and I can say that sine of theta is the reciprocal of cosecant, right? So it's 1 over cosecant of theta, and cosine of theta is 1 over the secant of theta, and the tangent of theta is 1 over the cotangent of theta. So these 6 you really already know. They're just reciprocals, they go either way, and so you really already know those. Those aren't anything new you're going to have to memorize. Now ratio identities you probably don't know. Tangent of theta is one of our ratio identities because remember we said it was y over x, but remember I can replace the y with sine of theta, and I can replace the x with cosine of theta. So then what's another way I could represent the cotangent of theta? Well, it's the reciprocal of my tangent here, right? So it's going to be cosine of theta over sine of theta. So the ratio identities, you're just replacing the x with cosine and the y with sine, and you get your ratio identities. Squaring creates a new identity. You can take any of them and square them. So for example, I could take tangent squared of theta, and it would be equal to sine squared of theta over cosine squared of theta. Or I could take one of my reciprocal identities, such as cosecant squared of theta would have to be equal to 1 over the sine squared of theta. But be careful, you can't combine squareds and not squareds. You can only use the squared ones together. Pythagorean theorem. Okay, we just said a few minutes ago, and I'm going to change the order of this just because I like it this way better. Sine squared of theta plus cosine squared of theta equals 1. Remember, I just showed you up here a minute ago how we got that. Okay, we just replaced our Pythagorean theorem with our cosine and our sine, but I changed the order of it. Now, if we did something to this, okay, let's say I divided them all by sine. So I'm going to do this off to the side. So if I took my original one, this shouldn't be too hard to memorize, right? These are called the Pythagorean identities because you're squaring everything to get the answer. But let's say I divided all of these by sine squared. Because if I do the same thing to everything, it's okay to do. So let's see what we have. Sine squared theta divided by sine squared of theta is 1. Cosine squared of theta over sine squared of theta is going to be, remember that's the reciprocal of the tangent, so it's going to be the cotangent squared of theta equals, and then 1 over sine squared, so that's the cosecant squared of theta. So my second Pythagorean identity is 1 plus the cotangent squared of theta equals cosecant squared of theta. What if I took this same starting one, sine squared of theta plus cosine squared of theta equals 1, and I divided everything by cosine squared of theta. So if I divided by cosine squared of theta, cosine squared of theta, and cosine squared of theta, I would end up with, well, sine squared over cosine squared of theta is going to be tangent, so this will be tangent squared of theta, and cosine over cosine, that's going to be plus 1, equals 1 over cosine squared of theta, that's going to be secant squared of theta. So my third Pythagorean identity is tangent squared of theta plus 1 equals secant squared of theta. So do you have to memorize all of these? Not to me. If you just memorize the first one, if you memorize this one right here, and then you just think about dividing by sine, you can get the second one. Think about dividing by cosine, you can get the third one. So I just memorized this one. So what you really need to memorize is this one, sine squared theta plus cosine squared of theta equals 1. And you need to memorize the tangent. The tangent of theta is sine theta over cosine theta. Most of the other ones you know already. So just to show an example of what we're going to do with this, we're going to simplify each expression to a single trig function or number. Well, there's nothing I can really do with the sine of theta, so I'm going to leave it like that. But the cotangent, could I rewrite that with a sine involved? Well, remember up here a minute ago we had tangent of theta is sine over theta over cosine theta, and cotangent theta was cosine theta over sine theta. So I'm going to replace the cotangent with cosine theta over sine theta. So all I did is take this one and replace it with what I know it's equal to. And now what's going to happen, since this is over a 1, my sine thetas cancel out. And it can be written just as the cosine of theta. Let's look at another example. So, well, I think about sine squared of theta over cosine theta. I don't think I can really change that much right now, so I'm going to leave that there. But I do know that I could change cosecant of theta to what? 1 over sine theta. And then what's going to happen? Well, these two are going to cancel out. And I'm going to be left with just one sine of theta up here. So I end up with sine theta over cosine theta. So it's still not 1 yet, but we learned up there a minute ago that what's equal to sine theta over cosine theta? Tangent of theta. So you have to memorize that so that you're easily able to go back and know that I can replace tangent of theta with sine theta over cosine theta. Now this one's tricky because we know that we can replace cosecant of theta with 1 over sine squared of theta, right? And what is the relationship we learned about sine and cosine squared? Remember, sine squared theta plus cosine squared of theta equals 1. So if I rewrote this, okay, if I moved this over there and made it negative, I would have sine squared of theta equals 1 minus cosine squared of theta, right? So this can be replaced by this. So I'm going to multiply this times sine squared of theta. And I like using theta, but I could use x like I really used in the example there. So what's going to happen? These are going to cancel out, and the answer is just 1. So the reason these problems are tricky is because it's not obvious. You have to think about it. So when we get to class, we're going to work on these, and we're going to work together in groups so that you can figure out how to rewrite these expressions and eventually solve trig proofs.